Hi there. Today we are going to learn about interpreting real life graphs. So if we look at the first example here, this graph shows the speed of a car during a journey. As you can see, the horizontal axis, if we would like to call it the x-axis, represents the time, and perpendicular on it is the speed in kilometer per hour. What time? So from the graph, we need to answer the questions. What time did the car set off on its journey? Which means what time did the car start the journey? As you can see here, this is the starting point. So it started at 15:00 and 15, or we can put here the answer is, some people would like to answer it this way. If 1 is 13, 2 is 14, so we're going to write it as 3, but don't forget to write PM. How fast was the car traveling at 15:30? So as you can see here, 15:30, so here, which means here, it was 15:30, and the speed, if this is 100, 110, 120, 130, 140, 150. So it will be 120 kilometer. How fast? It's a speed per hour. For how long did the car travel at 90 kilometer? So if this is 100, this is the 90. As you can see, once again, this is the 90. Okay, so 50, 60, 70, 80, 90. So if we go over there to here, and for how long did the car travel? And so it started at 15, and to 16 it's 1 hour, to 16:30 it's 1 hour and 30 minutes. 1 hour and 30 minutes. So for how long did the car travel at 90 kilometer per hour? So this is the 90, and so the answer will be 1 hour. So this is the 90. And if we go to here, it started at 15. So it traveled for 1 hour. The car was traveling behind a slow lorry for part of the journey. Between what times was this? The car was traveling behind a slow lorry for part of the journey. In which part was this? It was between, as you can see here, it was traveling from 15 to 16:30 at a constant speed, and from 16:30 to 17 the car was slowing down. So The car was traveling behind a slow lorry for part of the journey. Between what times was this? Between 16:30 and 17 and 17. Okay, next. How far did the car travel between 15 and 16:30? So 15 and 16:30, this is 1 hour and a half. 1 hour and a half, right? And the speed from 15 to 16:30 was 120 kilometer per hour. So the speed 120, so speed is equal to distance over time. How far? It means that we are finding the distance. So the distance equal speed times time. The speed is 120 times 1.5. And the answer will be 180 kilometer. How far did the car travel on the whole journey? How far did the car travel on the whole journey? So, from 15 to 16:30, it traveled 180 kilometer. From 16:30 to 17, which is 0.5, it's a half an hour, and at a speed of the speed here, so 50, this is 40, 30, at a speed of, so 0.5 hour at speed of 30 kilometer per hour. So the distance is equal to speed times time, so it will be 30 times 0.5, and the answer will be 15 kilometer. And then from 17 to 18, it's 1 hour, so 1 hour, and the speed was, as you can see here, 90. Speed was 90 kilometer per hour. So the distance is equal to speed times time, and it will be 90 kilometer. So if we add here the 180 plus 90 plus 15, the answer will be 180 plus 90 plus 15, it will be 285 kilometer. So this is the first example. The second one, here is a description of a woman's. So here they gave us the graph and we needed to get the information out of the graph. Here they want us to draw the graph. Here is a description of a woman's run. She sets off, she starts her running at 9. So we will start drawing from 9. Okay, let's see what her speed. She runs at a constant speed of 8 kilometers per hour. So if this is 5, 6, 7, 8, so 8, so we will start here. So she runs at a constant which is 8 kilometers per hour for the first hour. So from 9 a.m. to 10 is 1 hour. So here we go. Okay, and then she stops and rests for 15 minutes. She stops and rests for 15 minutes. So it's like we're going to here to 0, 0 and 15 minutes. So if this is 10, this is the 30. So it's going to be somewhere in between, And we're gonna go up, 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 up. So after the 15 minutes, after her rest, she runs at a constant speed of 11 kilometers per hour. So we're going to go to the 11, which is here. And let's say that approximately she starts from here once again and for 20 minutes. So if from here to here is 15 and for what 20 minutes so from here to here is 15, and let's say that it's up until here or here, for example, approximately. So this is the graph and the description for it. She starts at 9. She runs at a constant speed of 8 kilometers per hour for 1 hour, and then she rests here for 15 minutes, and then she runs at a speed of 11 kilometers per hour for another 20 minutes. So that's how we draw the graph. Let's go to the third one. The distance graph shows Econ's walk to meet a friend. So let's have a look. What speed is Econ walking from A to B? What speed is Econ walking from A to B? So from A to B, it starts here, and the distance is 4 kilometers. So the distance is 4 kilometers, and the time, so this is minutes, time is equal to 30 minutes, which is equal to 0.5. How I know that it's 0.5? Because 1 hour is equal to 60 minutes. So 30 minutes, you're going to say 30 divided by 60, which is going to be 0.5 hour. Okay, so like we said, the speed is distance over time. Let's substitute, it's 4 over 0.5. And the answer will be 8 kilometers per hour. B. When Econ meets his friend, they stop and talk. Between which 2 points they stop and talk? As you can see here, it's between B and C. So it's between B and C. Between point B and C. Because Econ does not get any further from or closer to home, so he must be standing still. So because the straight line shows that Econ is standing still, and that he's not moving away or closer to home. Okay, Eakin borrows a friend's bike to travel home. What speed is he going when he is traveling back home? Okay, so he started from D to E to go back home, okay, using a bike. So the starting point at 1:10 and then the ending point, let's say approximately at 1:35. So from 1 to 10 to 1:20, 10 minutes, and from 1:20 to 30, 20 minutes. So let's say 25 minutes. And like we explained here, 1 hour is equal to 60 minutes. So 25 minutes divided by 60, the answer is 0.42 hours. Okay, so the time, as we explained up there, is 0.42 hours. And the distance, as you can see from here to here, is 6 kilometers. So the distance is 6 kilometers. So the speed is equal, again, distance over time. So it will be 6 over 0.42. And the answer will be 14.3 kilometer per hour. Okay, 2 car rental companies are advertising their prices for renting a car. Company A, 80 for the first day and 25 extra for extra day. Company B, $60 for the first day and 30 per extra day. And this is the graph of the two companies. Let's start with the first question. Michael wants to rent a car for 3 days. So for 3 days. So if we say here, company A and then company B. So company A, if we go up there once again, it's 80 for the first day. So the cost is 80 for the first day plus, so 2 because they're renting it for 3 days, times 25 for each day after the first day. So 25 times 2. So the first day is 80. The next 2 days is 425. Accordingly, the price and the cost for B, it will be, if we go up there, so it starts at $60 the first day plus $30 for the next day. So and we're renting it for 3 days. So the first day is 60 and then 2 days times 30. So the answer will be, so 80 plus 2 times 25, it will be 80 plus 2 times 25, it will be $130. And 60 plus 2 times 30, it will be $120. So which one is cheaper? So company B is cheaper by $10 because 120 is less than 130. Okay. Okay, so after how many days does it become cheaper to rent with company A? So as you can see the graph here, this is company A and this is company B. One of the common mistakes that some people say at the 5th day. At the 5th day, the prices of both companies of A and B is going to be the same. And there is no such a thing after 5.5 days. So definitely after the 6th day. So after how many days? After 6 days, company A becomes cheaper than B because the line graph of A goes lower than the line graph of B. All right. Next, we have twin babies washed in a small bath. This graph shows the water level in centimeters in bath over time. So let's have a look here. So this is the water level that's going up and down, and this is the time. Give possible explanation for the shape of the graph during the first 5 minutes. So the first 5 minutes we're starting here, and this is the time. So 5 minutes it's until here. So as we can see, the bath is being filled from the top. So the level of water is rising up. So we're going to say the level of water is going up or increasing, which means that the bath is being filled from a tap that's flowing at a constant speed. Next, give an explanation for the shape of the graph after 5 minutes. The explanation, so it's rising from 10 to 20 centimeter, which shows that one of the babies must have been placed in the bath. So the level of water is increasing by 10 centimeter by 10 centimeter, which means that one of the two babies must have been placed in the bath. Give an explanation for the shape of the graph at 10 minutes. So at 10 minutes, as we can see, the level of the water went up again from 20 to 30, by another 10 centimeter, which means that the second baby must has been placed in the bath. So the level of water is going up again or further, which shows that the second baby must has been placed in the bath. Okay, and then for how long were both babies in the bath together? For how long the two babies stayed in the bath together? So as you can see here, so it started, we filled the bath with water at minute 5. One of the babies has been placed inside in the bath, and then at minute 10 or after 5 minutes, the second baby was placed in the bath, and here the level of water before it started to go down, it was constant from 10 to 20, and the difference from 10 to 20 is 10 minutes. So they stayed in the bath for 10 minutes. Give an explanation for the shape of the graph at 20 minutes. So if you go here at 20 minutes, both babies have been taken out from the bath. So because the level of water went down, so we're going to say here the level of water went down, which tells the both babies have been taken out from the bath at the exact same time. Okay, and this would be the end of our lesson today. Please go through the questions once again and keep solving them until you feel that you nailed it and you understand how to figure out every and each question in it. Thank you for watching, and I will see you in the next video sometime soon.